Did you know that your car's engine requires the correct amount of air and fuel mixture at the right time to run efficiently and smoothly? This was ensured by carburetors in older engines, but today, those carburetors are replaced by the more efficient and effective system, known as the fuel injection system. A fuel injection system is a vital component in a car's engine that delivers fuel to the combustion chamber. It is responsible for providing the right amount of fuel to the engine at the right time to ensure efficient, accurate, and reliable operation, making it the preferred system in modern vehicles. So, in this video, we'll explore the different types of fuel injection, how they work, what benefits they offer, and why they're so essential for today's cars. Parts and working of fuel injection system. The fuel rail is a manifold that connects the fuel injectors to the fuel supply. The fuel rail is usually located near the engine's intake manifold or cylinder head. The fuel pump is responsible for delivering fuel from the fuel tank to the fuel injectors. The outer part of the injector, called the injector body, houses several parts, including the nozzle, electromagnetic coil, fuel filter, and fuel inlet. The body is typically made of metal, such as steel or aluminum, and is designed to withstand the high pressure and temperatures that occur in the engine's combustion chamber. The fuel inlet is where fuel enters the injector from the fuel rail. The fuel filter is located inside the injector and removes impurities and contaminants from the fuel before it is sprayed into the engine. Also, there is an arrangement of an electromagnetic coil, plunger, pintle injector, and nozzle. Once the fuel is inside the injector, the gas hangs out in the reserve, waiting for the right moment to spray. Then, when it comes a time, an electromagnetic coil pulls the plunger up, opening the pintle injector and spraying fuel out of the nozzle. The nozzle is part of the injector that sprays the fuel into the engine's combustion chamber. It is typically located at the end of the fuel injector and is designed to create a fine mist of fuel that is easily ignitable. The injector sprays multiple times every second, and every sprays an exact amount of fuel. The timing's controlled by an electrical signal from the car's ECU via an electrical connection, and it works with the spark plug to create power. Some fuel injectors have a built-in pressure regulator that ensures that the correct amount of fuel is delivered to the engine. The pressure regulator works by monitoring the fuel pressure in the fuel lines and adjusting the flow of fuel as needed to maintain consistent pressure. If the pressure becomes too high, the regulator will reduce the flow of fuel to bring it back down to the appropriate level. If the pressure drops too low, the regulator will increase the flow of fuel to raise the pressure. The ideal air-fuel ratio for combustion in a gasoline engine is typically around 14.7 to 1, which means that 14.7 parts of air are required for each amount of fuel. This is known as a perfectly balanced stoichiometric air-fuel ratio, which is the ratio that provides complete combustion of the fuel with no excess oxygen or unburned fuel. Any mixture greater than 14.7 to 1 is considered a lean mixture. Any less than 14.7 to 1 is a rich mixture. The air-fuel ratio is controlled by many factors that are pre-programmed into the engine control unit, ECU, using a variety of sensors and actuators. This begins with the mass air sensor, throttle position sensor, and manifold absolute pressure sensor. These sensors give the computer an idea of how much throttle you are giving the engine and how much air is going into the engine. It takes that information and uses an oxygen sensor and coolant temperature sensor to determine the appropriate amount of fuel to inject into the engine. Based on these inputs, the ECU calculates the air-to-fuel ratio and sends a signal to the fuel injectors to spray the appropriate amount of fuel into the engine. This is a very basic explanation of what is going on. The ECU does thousands of calculations based on more of this. Before going to the types of fuel injection system, let's take a look at difference between a carburetor and fuel injection system. The carburetor was phased out of the automotive industry by the 1990s, with fuel injection taking place and gaining prominence. The carburetor had many setbacks and cannot be used in diesel vehicles. On the other hand, fuel injection is available for both diesel and gasoline vehicles in electronic and mechanical variations. The carburetor is a device that mixes air and fuel in the required ratio before letting it into the combustion chamber. It is technically simple, inexpensive, easy to maintain, and most importantly, it does not require electricity. Instead, it uses the engine's natural air suction. Before the new era of microchips and complicated automotive electronics, carburetors prevailed on the market. Its major disadvantage is that a single carburetor supplying a 4-cylinder engine cannot give each cylinder precisely the exact air-fuel mixture, because some of the cylinders are further away from the carburetor than others. One solution is to fit twin carburetors, which are difficult to tune correctly. Instead, many cars are now equipped with fuel-injected engines where the fuel is delivered in precise bursts. Engines so equipped are usually more efficient and more powerful than carbureted ones, and they can also be more economical. Another difference between a carburetor and fuel injection is that fuel injection atomizes the fuel through a small nozzle under high pressure, while a carburetor relies on suction created by intake air accelerated through a venturi tube to draw fuel into the airstream. Modern injector systems are controlled electronically, they are much more accurate and can cope with strict emission standards. They help you save fuel, provide more power at lower engine speeds, and increase overall stability. Additionally, it provides better engine performance, smoother idling, and faster engine response. Fuel injection also reduces harmful emissions from the car, making it somewhat better for the environment. In general, a good fuel injection system is more accurate than a carburetor. This system delivers the exact amount of fuel needed, no matter the conditions. A carburetor cannot adjust for the fuel intake ratio, so it is less accurate. Overall, fuel injection is a modern technology that helps car engines run more efficiently, reliably, and cleanly. Now let's take a look at different types of fuel injection systems, starting with the throttle body injection system. It is also known as single-point injection, because it uses a single injector located in the throttle body to deliver fuel to all cylinders. In single-point injection, the fuel is injected into the throttle body and then mixed with air as it passes through the intake manifold and into the cylinders. It was commonly used in older vehicles and is now less common due to its limited precision and efficiency. At that time, throttle body injection was developed as a replacement for carburetors. This system uses a single injector located in the throttle body to deliver fuel to the engine, which provides better fuel metering and control than a carburetor. While the basic function of throttle body injection and a carburetor is similar, mixing fuel and air before delivering it to the engine, throttle body injection is more precise and efficient. As air enters the throttle body, it passes over the fuel injector. The ECU calculates the precise amount of fuel needed based on inputs. Even though the engine has 4 cylinders, the number of injectors remains 1. However, because it only uses one injector, the engine's performance at high RPM is also slightly disturbed. Port or multipoint fuel injection is also known as an indirect injection system. In port injection system, the fuel is injected into the intake port, rather than directly into the engine cylinder. Each cylinder has a fuel injector located in the intake port of the engine, which sprays fuel into the intake manifold just before the intake valve opens. The fuel mixes with the incoming air and is drawn into the cylinder when the intake valve opens. The word multipoint fuel injection means the fuel is injected into the intake port of each cylinder, individually through a separate injector. Each cylinder has its own fuel injector, which means that a 4-cylinder engine uses 4 injectors that are mounted on the intake manifold near the intake port. It is less precise than direct injection but can still provide good fuel efficiency and engine performance. Shooting the fuel vapor this close to the intake port almost ensures that it will be drawn completely into the cylinder. The main advantage is that multipoint fuel injection meters fuel more precisely than throttle body injection designs, better achieving the desired air-fuel ratio and improving all related aspects. In the early 1900s, Bosch and Clessie Cummins decided to improve Rudolf Diesel's original air-blasted system by introducing a new fuel injection system. This involved injecting fuel directly into the intake port, where it mixed with the incoming air. From there, the spark plugs ignite the pressurized slurry of air and fuel, pushing the cylinder head down and spinning the crankshaft. This process occurs simultaneously in each cylinder of the engine. For example, in a V6 engine with port injection, the cycle happens so rapidly that it is barely noticeable except for the sound it produces. There are three types of multi-point fuel injection systems available. They are sequential, batched, and simultaneous system. Sequential systems. The sequential fuel injection is also called sequential port fuel injection or timed injection. This system is designed to inject fuel into each cylinder in a specific order. Basically, the sequential fuel injection system is the same as multi-point fuel injection, but this type already has individual injection. In other words, each injector does not work together but works individually according to the steps of each piston. For example, in a 4-cylinder engine, when cylinder 1 is in the suction step, only injector 1 works, while the other injectors are idle. The injectors are controlled by the engine control unit, which ensures that each cylinder receives the correct amount of fuel at the precise moment it is needed. Sequential fuel injection triggers each injector nozzle independently. Timed like spark plugs, they spray the fuel immediately before or as their intake valve opens. Sequential systems are the most precise and efficient type of multi-point fuel injection system. Batched systems. In the batched system, fuel is injected into the groups or batches of the cylinders without bringing their intake stroke together. This means that fuel is delivered to sets of cylinders at the same time, rather than to each individual cylinder during its specific intake stroke. In a typical 4-cylinder engine with a batched system, the injectors may be divided into 2 groups, each supplying fuel to 2 cylinders. The engine control unit activates one group of injectors to deliver fuel to cylinders 1 and 4, while the other group delivers fuel to cylinders 2 and 3. The injection timing and duration are controlled by the engine control unit to ensure that each cylinder receives the correct amount of fuel at the right time. This system is simpler and less expensive than sequential systems, but they may not provide the same level of precision and efficiency. Because the fuel is delivered in batches, there may be slight variations in the amount of fuel delivered to each cylinder, which can affect engine performance and emissions. Simultaneous systems. In the simultaneous system, fuel is injected into all cylinders at the same time. It uses an individual fuel injector for each cylinder. Thus, there is no gas wastage over time. It reduces fuel consumption and makes the vehicle more efficient and economical. The vehicles with this technology have lower carbon emissions than a few decades-old vehicles. The more precise fuel delivery cleans the exhaust and produces less toxic byproducts. Therefore, the engine and the air remain cleaner. The multi-point fuel injection system enhances engine performance by atomizing the air in a small tube instead of relying on the additional air intake. It also improves the cylinder-to-cylinder fuel distribution, which further aids in improving engine performance. This automobile technology improves the engine response during sudden acceleration and deceleration. Direct injection. In a direct injection system, fuel is injected directly into the combustion chamber of each engine cylinder, rather than into the intake valve, so that it looks like a diesel engine, where the injector will spray fuel directly into the cylinder. Typically, the fuel is injected during the compression stroke of the engine. This allows for better control over the fuel and air mixture and can result in improved engine efficiency and performance. This is the latest type of fuel injection system. In early, the direct injection was applied to diesel engines. But now, the direct injection system can be used for the gasoline engine, but still, the fuel only comes out during the suction step. For the gasoline engine, this system is known as gasoline direct injection or GDI. So, how it works? The high-pressure pump increases the fuel pressure to 502,000 pounds per square inch. Once the fuel is pressurized, it is sprayed through a small nozzle directly into the combustion chamber during the engine's compression stroke. The fuel is sprayed in a fine mist that is highly atomized, allowing it to mix more completely with the air. The fuel mixes with the air in the combustion chamber, creating a highly combustible mixture that can be ignited by the spark plug. When the spark plug ignites the air-fuel mixture, it creates a controlled explosion that pushes the piston down and turns the crankshaft, generating power to move the vehicle. By injecting fuel directly into the combustion chamber, direct injection systems can provide more precise control over the fuel-air mixture, resulting in improved fuel efficiency and engine performance. They can also reduce emissions by more effectively burning the fuel. Direct injection systems can be more complex and expensive than other types of fuel injection systems, and they require higher fuel pressures and more precise control over the fuel delivery system. Direct fuel injection systems in gasoline engines can be classified into three types, which are spray-guided, wall-guided, and air-guided injection. In the spray-guided direct injection system, the fuel injector is typically located in the top of the combustion chamber next to the spark plug. The fuel is sprayed directly into the combustion chamber in a way that creates a specific pattern or spray shape. This is done to ensure that the fuel is distributed evenly throughout the chamber and that it reaches all parts of the chamber before ignition. This is designed to maximize fuel atomization and mixing with the air in the combustion chamber. However, it requires careful design of the combustion chamber and fuel injector to optimize the fuel spray pattern and avoid undesirable combustion characteristics, such as knock or incomplete combustion. In wall-guided direct injection, the fuel is injected into the combustion chamber in such a way that it strikes the walls of the chamber before being mixed with air. The distance between spark plug and injection nozzle is relatively high. In order to get the fuel close to the spark plug, it is sprayed against a swirl cavity on top of the piston, which guides the fuel towards the spark plug. This method of injection typically requires a higher injection pressure than the spray-guided method. In engines with wall-guided injection, special swirl or tumble air intake ports aid this process. The injection timing depends upon the piston speed, therefore, at higher piston speeds, the injection and ignition timing need to be advanced very precisely. At low engine temperatures, some parts of the fuel on the relatively cold piston cool down so much that they cannot combust properly. When switching from low engine load to medium engine load, some parts of the fuel can end up getting injected behind the swirl cavity, also resulting in incomplete combustion. Engines with wall-guided direct injection can therefore suffer from high hydrocarbon emissions. In engines with air-guided injection, the distance between spark plug and injection nozzle is relatively high. The air intake is used to guide and direct the fuel spray into the combustion chamber. The shape of the combustion chamber is typically designed with a small centrally located injector that sprays fuel directly into the cylinder. The air entering the cylinder is directed by the shape of the chamber, creating a vortex that helps to mix the fuel and air together. The design of air-guided injection systems can be more complex and expensive compared to other types of injection systems, which may limit their adoption. Dual injection system. Dual injection systems use two different methods of injecting fuel into the engine: direct injection and port injection. It is commonly found in modern gasoline engines and is designed to improve engine efficiency. In a dual injection system, there are typically two types of injectors: a high-pressure direct injector and a low-pressure port injector. The direct injector injects fuel directly into the combustion chamber, while the port injector injects fuel into the intake port of the engine. At low RPMs, the system will rely mainly just on the port fuel injector that provides a better air-fuel mixture. This means that the engine will gain all the port fuel injection advantages. However, as the RPM increases, the direct injector steps in and the port injector stops. This increases the combustion efficiency since the direct injection system is faster at higher RPM and could perform better. When the RPM increases more and more, and the direct injector is not capable of providing enough fuel at such high speed, the port injector will be there to help. Both injectors will be working together at high RPMs to supply the cylinder with the needed amount of fuel. Advantages of dual injection system. While both port and direct injection systems have their own advantages, they also have some drawbacks that can be overcome with the use of dual injection system. Carbon deposits. Direct injection engines are prone to carbon deposits on the intake valves because fuel doesn't wash over them. In port injection engines, on the other hand, injects fuel into the intake manifold, allowing the fuel to wash over the intake valves. While this can help prevent carbon buildup on the back of the valves. However, by combining both systems, the dual injection system can reduce the formation of carbon deposits by using the port injectors to wash the intake valves. Engine knock. Direct injection can lead to engine knock or detonation because of the higher compression ratios and cylinder pressures. Port injection, on the other hand, can reduce the likelihood of knock because the fuel is introduced before the air enters the cylinder. By combining both systems, the dual injection system can reduce the risk of engine knock while still providing the benefits of direct injection. Fuel efficiency. Direct injection can improve fuel efficiency by delivering fuel directly to the combustion chamber, but it can also lead to incomplete combustion and higher emissions. Port injection can help to ensure that the fuel is fully mixed with the air, but it can also reduce fuel efficiency. The dual injection system can optimize fuel delivery for different driving conditions, improving overall fuel efficiency while reducing emissions. So, in order to combat the drawbacks of both port and direct injection systems, car manufacturers decided to combine both port and direct injection into one setup. Interestingly, combining these two systems adds the advantages together, but it gets rid of all the drawbacks. The only disadvantage of this system is the increased number of moving parts and the increased production costs. I hope you enjoyed learning about fuel injection systems. If you have any questions or comments, please feel free to leave them below.